Hi, everyone. Hi. Thank you so much for coming back to the Rockbond Art Museum RAMa 2025 today on a Sunday afternoon, scorching hot and may have a chance of raining, but we are super blessed that the rain is not coming down. So today is the Sunday of our opening weekend of RAM Assembles, which is a biennial of architectural festival and discussion that we host in the neighborhood of Rockbond. And this year, we have the privilege to have Ozong team here with us who directed the whole program for the biennial, as well as building and designing the installations that you are all sitting under, which is called Under the Common Sky, which is a shelter that is sheltering us from the rain and sun. And so we are super, super, super appreciative today also to have Mae-ling Lokko, who just joined us from Japan today. And Mae-ling will be talking to us today about the idea and the notion of comfort and how that is negotiated throughout the world under different climate conditions. So without further ado, I will give some biographic parameter of Mae-ling. And then also, after Mae-ling's talk for about 30 minutes, Mae-ling will be in conversation with Marcela Godoy, who is based in Shanghai, a professor at NYU. So Dr. Mae-ling Lokko is an assistant professor at Yale University School of Architecture and Yale Center of Ecosystems in Architecture, and the founder of Willow Technologies Limited in Accra, Ghana. Her research focuses on the whole life cycle development, distributed infrastructure design, and policy around non-toxic, low-carbon materials. Mae-ling previously taught at Cooper Union and Rensselaer Polytechnic Institute, where she served as the director of Building Sciences program, as well as assistant professor at the School of Architecture and Center for Architecture, Science and Ecology. Mae-ling's work has been exhibited globally, including at the Museum of Modern Art in New York, the Nobel Prize Museum in Stockholm, and the Museum of the Future in Dubai. Her research has been funded by United Nations Environment Programme, the Somme Foundation, ReArch Institute, the British Council, MIT's Global Architectural History Teaching Collaborative, Luma Foundation, and the New York State Energy Research and Development Authority. Mae-ling holds a PhD and Master of Science from the Center of Architecture, Science and Ecology, and BA from Tufts University. Mae-ling currently serves on the board of the International Living Future Institute and the Architectural Lead of New York. And also, in conversation with Mae-ling afterwards is Marcela Godoy, who is a practice-based researcher utilizing critical making and fabrication technologies to explore architectural possibilities and address environmental challenges. She's an associate arts professor and the area head of interactive media arts at NYU Shanghai. Over to you, Mae-ling.
Hi, everyone. Thank you, Joni, and thank you all for being here. I'm going to try to speak slow for the translator. But yeah, it's fantastic to be here in Shanghai. It's my first time. And to talk about a topic close to my heart, because we're all facing a shift in our climate, and our lifestyles have also drastically changed. Our expectations around comfort and the built environments have also changed. But I'm going to start off with, where this interest began. Over the past 15 years, I've been working with plants. Plants are, in many senses, our ancestors on this planet. They've lived here for a significantly longer time than us, with evidence suggesting that they appeared over 500 million years ago during the Cambrian period. The first plants were soft, algae, marine-like organisms that prospered on the edge of water. And with the help of their fungi friends, over time they developed root-like rhizoids and enable them to anchor onto terrestrial rock, as well as a waxy skin, which help them essentially conserve water. So it's a sort of interspecies collaboration. But because plants can take energy from the sun and carbon dioxide out of our atmosphere to grow, we as animals have relied on them greatly for survival. 287 million years later, large animals were thriving, and the modern version of our species only evolved somewhere around 300,000 years ago. So we are nowhere in sight on this timeline. Plant families have been residents 1,600 times longer than we have here. And not only do they precede us, but they outnumber us in scale. In a seminal study about 5 years ago, estimating all the weight of life on the planet based on carbon, this kind of shows, if you're an architect, if plants were an 18-story building in green, essentially all animals in the orange over there would only be a ground floor shop, and humans would barely cover the ceiling of that shop. So spatially, it gives you an idea that plants are the main residents and tenants on Earth. And there are obviously other kingdoms of life, fungi, protists, bacteria, who again outnumber us. If we were put on a seesaw with bacteria, we would go flying up in terms of mass. So given their seniority and their predominance, and because they are literally rooted into place, we have developed an understanding of our planet from them. So if we look, in terms of the different climates, the Köppen climate classification system, the best evidence over time to tell what the climate and soil conditions were essentially plants. And as architects, we look to this, in terms of figuring out how to deal with climate from them. In this part of the world, not so far away, in the Malaysian peninsula, we see the multi-level sort of architecture of dense tropical forest show us, a sort of hierarchy in terms of not only climate, but how to protect and allow different plants to thrive and work together in that hot tropical environment. We've seen the sort of Malaysian kampung house. I don't know if anyone here has been to them, but essentially this genealogy of hot, humid tropical housing is almost like an embryo. You protect where humans are living by buffering them with verandas. You lift them off the ground so that the heat cannot be transferred to our floors, and you allow the wind to blow under them. You have large attics that help insulate from the harsh sun. But this sort of embryonic release as much heat and prevent as much heat gain as possible is in the hot tropical climates. When you go further north to Scotland, you can see again how we use plants to shield us. So literally the house is covered with oat straw, and you typically would never build beyond the size of your oat field. So after you harvest the oat straw, all of that straw is put on the roof. And after 14 years, when you're burning over time the soot in the middle of the house, all of that ash goes to the underneath of the ceiling, and over time becomes fertilizer, and the roof is returned back to the garden again. So it's sort of a very regenerative cycle, and it serves as insulation. And in other parts of the world, closer to Chile, where Marcela is from, even when there isn't land, fast-growing plants like reeds are used to reconstitute land itself, making up walls, roofing systems, and in many cases, even transport. These wonderful sort of balsa boats are essentially their own form of transport. Since the Industrial Revolution, we've seen a shift in our building culture where minerals begin to dominate. We've tapped deeper and deeper into our planet to power and to build with. And we've seen now a sort of renewed interest, I'm sure that's also happening in this part of the world, a renewed interest in working with lower carbon, healthier materials, plant-based materials in buildings. And while it has been extremely exciting to see this interest in natural materials once again, it's also scary because when we think about our models of scaling plants, you think about the big four, sugar, corn, rice, and wheat. Their models of scaling have introduced a lot of problems. Beyond monocultures, we've seen the transatlantic slave trade in terms of labor systems, and also all of the derivative impacts when we have a surplus of agricultural waste. They begin to flow into other parts of life, displacing the use of other materials, and I'll talk about that later. So 2 years ago, we were commissioned by the United Nations Environment Program to do a status study of all of the dominant building materials on the planet, and to think about a strategy between now and mid-century for decarbonizing not just the conventional building materials, but how do we shift to bio-based building materials. And this was a very controversial graph. You can kind of see over here that bio-based materials in green is less than 10% of the materials we work with today. But by mid-century, we're arguing for them to become close to 50%. The scale at which we're asking these materials to be used and processed is not simple, and it will have huge effects on many aspects of our society, which I'll talk about. One of the biggest areas of potential has been agriculture, agricultural byproducts, mainly because they are so closely tied with our growth as a species. The more we grow, the more food we need. And often we see that of the food we grow, only 60% actually makes it onto our plate. About 40% is lost somewhere between the farm and out of our restaurants, out of our homes. And so it's a massive material resource that we can start to look at for building with. And so I'm going to talk about today some of the biggest challenges, in terms of reintroducing these materials into contemporary construction. I'm going to talk about 3 projects that illustrate some of, the challenges in many ways, and they all sort of link with comfort. And I want to start off with this graph. This was in the United Nations report, because you can kind of see something here in terms of our contemporary building materials. You can see steel, that's a really high emissions, carbon emissions in the middle over there. And to the right of it, at the very end, you can see a bio-based material, laminated bamboo, which might be common here, right, as an alternative to plywood or reconstituted wood products. And it has as much carbon emissions, almost equal to that of steel, which is crazy. And I like to call this the key example of material Botox. It's a term that we came up with to describe a sort of approach we have today to bio-based materials when we force them to do things that they may not be good at doing, or we use them to mimic things like cross-laminated timber, CLT. And so we pump them with glues. We're like, don't move, don't breathe, don't age, just stay young forever. And in doing so, we introduce a lot of toxic chemicals into them, and often the carbon emissions goes through the roof. And so this concept of breathing materials, going back to some of the vernacular examples that I showed, was one of the things we started to promote. How do we make materials just as strong, but materials that can still breathe? And it really began with the coconut husk. Over the last 15 years, we've seen sort of a huge global boom. Coconut became a superfood. Coconut water, coconut oil, coconut milk. There are just so many uses of coconut promoted for their health benefits. And it's sort of a symbol of many other things that are happening with bio-based materials. But one of the most interesting things is when you think about the first life of a coconut and what the protective layer, the husk, has to do, it's incredibly porous. It's filled with air, so much air that it can actually hold over twice its weight in water. And imagine it's on a beach, it's dealing with high heat from the sun, salty conditions, pretty poor soil nutrients, a lot of wind. It has to protect while keeping the luscious interior coconut meat and water safe and regulated in terms of temperature. And so we started to think about, this huge underbelly of the coconut food industry where I'm from in Ghana. Often people throw this on the roadside, but this is sort of an image of it on a farm, but they form mountains because the husk is such a strong material that it's actually illegal to dump it in the waste municipal systems. So when you break down the coconut husk, you find these amazing, strong tensile fibers and this dust-like substance called pith, which looks kind of like soil. This sort of exacerbated the coconut marketing campaigns, has exacerbated the production of this husk material. One of the things we realized over the 10 years we were developing coconut applications for buildings was there's always a spectrum of pathways. Sometimes when you think of cement-based technologies, steel, glass, they're good at doing very specific things well. But natural fibers are used for 1,000 different things. They are brooms, they're mats, they're roofing materials, thatch. And so this spectrum, we make a choice. Do you make it stronger by pressing it, adding pressure to it so that it can become as strong as oak wood? Or do you keep it light and fluffy and breathable? Holding moisture from our humid air, filtering. Almost everything we produce today is filtered by activated coconut carbon, which comes from the byproducts of the food industry because it's a very efficient filter because of all those pores that we just saw. And one of the most amazing things we found out when we were trying to make it stronger was the fact that if you use the actual pith, the dust, as the glue, you could keep the material breathable. So once you press the coconut fibers and the pith, you form essentially what are called high-density binderless boards. They don't require synthetic or toxic glues. And we started developing a range of materials. Initially, it was sort of a flat panel, something to substitute plywood or medium-density fiberboard, things that we can use in furniture for sheathing, all of the doors and stuff. But we realized that there was much more value we could add in terms of design, using the same amount of material, but understanding how form could improve its value. So we started to look at acoustic panels, mainly because you could sell a flat board for $2 to $3 a square foot, but the minute you make it an acoustic panel, it goes up to $60 a square foot, which is maybe one way to get it started. I'm not saying luxury is going to save the world, but it was one way to start. And we ended up exhibiting it in a contemporary arts festival in Ghana. This is sort of the flat board, we sort of mentioned. But we kind of developed a strategy to preserve its breathability. And you can kind of see here these simulations we had done studying the physical boards and how they breathe. Whether they're used on a roof or on the walls of a building, they essentially take all of the humidity out of the air, exterior air, during the early parts of the morning, late hours of the night. And then during the hottest part of the day, about 12 to 2 o'clock, they undergo a process called regeneration. So all of the moisture that is in them, in their pores, that takes on all of the heat from the sun. And then once they reach saturation, evaporation happens. So that moisture buffering and that heat is essentially why you feel so cool under a thatch roof or a building that has natural fibers. And so this breathing of the coconut board, even though it was quite a strong material, it looks dense, was something we don't necessarily find a ton of, in materials that we essentially Botox. We coat them and essentially stop this sort of movement of moisture across them. And I also wanted to show this because it's been very challenging getting people to shift their perceptions around these materials, particularly in the global south, in the global majority, because everybody wants to build with concrete, glass, and steel. Those are the materials that represent modernity. And I started looking to art exhibitions and cultural institutions as a place to start to engage the public around their meanings. And you'll see this in the couple of other projects. One of the ways we tend to do this on my team is to take these very powerful symbols of extraction. And so here, this is actually a response to the door of no return. These were the last thresholds that an enslaved person would have seen before entering a slave ship on the transatlantic African coast. And it's a haunting image if any of you have ever been to any of these slave forts. But to take that material ecology around the forts that were Portuguese, Dutch, British bricks, this masonry, and to shift it to materials from the coast, like the coconut. And this was called a door of return because it looks back at the shore. It's a reflexive, to look back at our land, to ask ourselves, what are the materials we want, to build comfortably with. And you can kind of see older coconuts disintegrating into the coconut pith at the bottom. They represent, that no coconut is ever created equal. If you get a coconut from Ghana, very different from another one from Sri Lanka or India. But that material variance is something we embrace in our work. And there you can see another shot of it. The second project starts to look at how we can integrate this into buildings. And again, it builds on some of the coconut work, the coconut acoustic panel. One of the things we realized we were doing, not too dissimilar from sugar, corn, rice, wheat, the big four monocultures, was we were taking the waste and exacerbating, promoting the coconut monoculture. So we went back to the farms that we were working with in Ghana, and we started to look around, even under the coconut trees, what else is grown around it? There's corn. The corn rhizosphere, the roots have their own fungi systems. There's a whole ecology around what seems to be a coconut monoculture. And we decided to take a different approach. How do we design for biodiversity? Work your way back. And so you can kind of see, even in proportion, the faster growing corn plants have much more straw stalk, which are fed to mycelium, the vegetative state of fungi. They take all the sugars out of the straw byproducts. And that becomes the core. We like to call it a Kit Kat. And we just keep the expensive coconut fibers in the interior and exterior. And essentially, this sort of biodiverse kind of panel became an approach, so that even seasonally, we can bring in very different crops into building materials instead of relying on one. That eventually affects ecological health. Mycelium also opened up a whole new world for us in terms of biodiversity, because one mycelium strain that loves to eat cellulose doesn't care where it gets its cellulose from. So with a foundation in the south of France, in Arles, called Atelier Luma, we started looking, 40% of all of organic food in France is grown in this region. And so they have an amazing biodiversity of crops. And so we started to look at everything they were producing: lavender, olive oil, sunflowers, stuff even coming out of kitchens, lemon peels, garlic peels, onion peels. And we started to explore, what could we do if we mix and match? If coconut husk fibers don't have enough sugar, can we supplement it with hemp that has much more sugar? Coconut fibers might be mechanically strong, and so you get a nice balance in terms of the final product. And so this ratio of sugars to the strong materials, the lignins in these materials, allowed us to open up the inventory, okay, that's awkward, of mycelium products. And you can kind of see a sort of semi-scaled up. This is a facility, our industrial partner in upstate New York. This is a mycelium factory, taking agricultural residues from all over the country, from the Corn Belt, from the hemp farms that are now growing throughout the country. And if you go to a mycelium factory, it's incredible. I mean, there's no loud machines. It's very quiet. It smells like mushrooms, which I don't know if I like the smell so much anymore, but There are many types of mycelium strains with their own smells. I feel like that's a very underexplored area. But essentially, the liquid mycelium is mixed with the agricultural waste, and it grows over 5 days. It used to take 12 days, but now it's gone down to 5, and you can grow it into customized forms. These would be fantastic as insulation panels, acoustic panels. And again, this sort of art exhibition setting, we started to look at meadows, a sign that land is beginning to heal at ZT3 in Belgium. And in it, we're grown a range of local herbs from the region in Hasselt. And so this sort of biodiverse myco-composites and the sort of corn, pressed coconut, corn composite became an approach that we've sort of grown. We've also looked at how to bring these buildings materials into buildings as a system. Given the fact that the coconut fibers, the coconut pith, the coconut activated carbon are so good at taking pollutants, toxins, and moisture out of our indoor air, we've looked at it going into ceiling, wall cavities, exterior envelopes, and inducing air into their cavities to dry them, to clean them. And so this was an example of using them in buildings to clean air, essentially, and to humidify air. And lastly, the last project I'll talk about is called Breathing Buildings, but it starts to look at this long history we've had with greenhouses, particularly because greenhouses were a building typology that was used to take plants that were grown in the tropics. It was very difficult to bring living plants back from the tropics, the subtropics, to the north without having a sort of environment where you could preserve the humidity and heat. And so in many ways, you know, tropical air, hot, humid air, was made possible by these large greenhouse structures. This is a photo of the Palm House in Kew Gardens. It unknowingly sort of introduced a whole mineral envelope, you know, where we had thermally massive masonry brick walls like the ones we see around here with air cavities in them. The greenhouse introduced the glass, like complete transparency, and the cold frame, the metal frame, in order to keep a very hot, humid environment for these tropical plants. And it essentially collapsed the building envelope. You know, it was completely relegated. All of the intelligence that we saw in the Malaysian house, in the Scottish black house, in all of the reed houses, all of those responsibilities of conditioning our indoor environment was relegated to mechanical systems, air conditioning systems, heating systems. And so all of these are many greenhouses that form part of the British Botanical Empire. These were places where plants were extracted from and brought to Kew Gardens, but they also became places where new hybrid plants were introduced, you know, to beyond the tropics, subtropics. So you can kind of see them spreading as far as Australia and, you know, above the United States of America. So this temperate greenhouse was a sort of typology that I started to look at in a lot of these more recent exhibitions. How could we take this symbol of extraction and start to reconstitute it with a range of materials that we've been developing at our lab at Yale? Some of them were the coconut husk, some of them were the myco-composites, but we've grown our research to also look at a range of earth masonry materials. And so the Kew Garden, Palm House, the Kew Gardens in England, and the Groves Tropenhaus in Berlin were two of the largest greenhouses and were seminal. So you can kind of see this exhibition, which was part of the Venice Architecture Biennale last May, where you begin to see a complete collaboration of a range of materials here. In white, those are the myco-composites, the mycelium fed with rice from, you know, the rice industry in Italy. In brown, we are actually using bioplastics, you know, things that are coming out of our plastics industry, as well as bounded by a geopolymer, materials that come out of soil. And this was a controversial tile because a lot of people said, why are you working with plastics? And one of the things we realized is we don't have the luxury of not working with plastics anymore because we have so much of it on our planet. And so we need time to dilute them so that they don't continuously flow into our oceans from land and runoff from land. And the built environment is a place to think about, their temporary storage. In brown, that's actually just a rice husk and geopolymer panel. And in black, we're actually looking at fly ash that comes out of rice production, the very end of many of these crop life cycles in that. And this is sort of a section of palm house using all of those 4 different materials. We scaled this up into an installation based on Grobes Treppenhaus in Berlin. And there you can kind of see the open roof, so really nice stack effect and cross ventilation. The gaps between all the panels are also about this idea of breathing. But the one thing there that we felt was key was to actually introduce on the surface of the panels materials that are actually accumulating on the West African coast. So we have huge amounts of textile waste. Where I come from, we're the second largest importer of secondhand clothing. They call it dead white man's clothing. And one of the things we've done is sort of shredded them and fed them to mycelium, or they're bonded at the surface of the other 3 panels. And it's sort of a whole catalog of finishes for the panels, again, diluting and storing them temporarily in the building. And that's just sort of an interior view of them. And it's incredibly cool in here in these buildings, given the panels are incredibly breathable, and there's a lot of room for ventilation in them. So I'm going to end there, and hopefully the Q&A can bring out some of the questions. I've sort of skipped across a lot of things, but hopefully this gives sort of a preview of some of the things we're working on.
Hi, I'm Marcela. Thank you so much, Johnny and Tintin, for inviting me and the opportunity to have this conversation with Mae-ling. I'm so excited to know more and to discuss about what you do, because your materials, you demonstrate that you can scale them up and show them as a real product. So your incredible work demonstrates that it is possible to design more sustainable materials when you collaborate with nature and also communities. Maybe you didn't mention so much about this, but I've seen your work, and you make farmers and traders allies in the process of making these materials. But unfortunately, this is not the standard practice in the market, and most of the companies are producing material and a lot of waste polluting our planet. So I would like to ask you, how do you envision the future of the industry if we want to create building materials from plants, but knowing that plants do not grow at the rapid pace of our economies and also our demands?
Yeah, thank you for that, Marcel. So maybe, the last part of your question, I think we always get this question, do we have enough plant-based materials to build the kind of housing that we're going to need over the rest of the century? And I think you saw that first image, and it's always why I begin with it. There is a ton of biomass on this planet, and most of it is combusted prematurely or downcycled. And often when we leave it on land, they actually become a risk because, we get under extreme events, fires, essentially. So there is a ton of biomass. The question is, how are we collecting them in time and processing them? And the how is really important. And again, we're dominated at scale with plant monocultures, and so that model has to shift. But I'm going to probably respond to that question of, how do we actually bring these materials a bit controversially, because after doing that UN report, we actually realized something. We were really hounded by the cement lobby. They did everything they could to discredit the report, and it really affects their bottom line, right? If half of building materials are no longer going to be cement, which cement is super large in terms of its share of conventional building materials. One of the things that a lot of biomass to bio-based building materials industry face is they don't have a consistent buyer. And if you think about all of the infrastructure it's taken and time it's taken to process minerals, even wood, I mean, these are super machines that take less than 10 minutes break a year. Biomass needs that same amount of time. And so ironically, I think companies like the big cement companies might be the ones to first usher in these materials as fly ash, because one can really replace the amount of cement we use in concrete masonry blocks, by using fly ash from biomass industries. And we see this happening in Senegal. The largest French cement company buys ground nut ash and replaces a percentage of cement with that. So they may be the first buyers. That gives biomass an opportunity to develop the machinery, build up and transition the workforce. And then, some of the midterm uses that we're thinking of, where it starts to replace quicker, faster moving materials in our buildings, because we renovate faster and faster, and we don't need everything to be made out of biomass. In fact, primary structure, it's too risky, in some cases, to make it out of biomass materials. So I think the people who've profited the most, essentially, have to play a huge role in this transition. And maybe it's a compromise we have to make, in the initial uses before we can get to some of the healthier approaches, that we'd like to see with these materials. Mycelium is a huge area, that I think there's a lot of potential there, because we are barely scratching the surface with mycelium. That's one strain, and everybody licenses one strain. In fact, I think it's a mycelium monoculture now. And it's incredibly based in a lab infrastructure. You are refrigerating, you're sterilizing, you produce a lot of plastic waste when you grow materials. And so I think we need to completely diversify. What is a mycelium from Shanghai like to eat? Can we start to look at that and produce under certain conditions that don't require as much energy, and recycle the plastics? So I think it's we need more collaborators. If there were many startups just doing this out on their own and taking the brunt of this transition, I don't think that's going to work.
Yeah, and following up with the speed of this material, you mentioned like the mycelium was growing 9 days or something like that, but now it's like 5 or 4, something like that. Do you think it's possible to create like these sustainable materials in collaboration with nature, but also changing designers' practices in regard to aesthetics and timelines? Because like all these materials look like natural materials. You are trying to, like you mentioned, material Botox, like not trying to impose maybe like a look or maybe the properties to them. So,
Yeah, I mean, that strain was genetically engineered, like modified, so that it would resist infections and grow faster. I think there's strains that go much faster. Like there's a strain we work with that only eats seaweed and it grows in 24 hours. So there's definitely a lot more to come, in terms of growing faster with algae materials, and there's just a whole range.
But maybe we need to slow down a little bit, waiting for these materials to grow.
Yeah, I mean, I hear you on that. I do. I think, there's a range of companies now. So when we began producing microcomposites, we had to take on the role of like manufacturer. But now we see new types of companies that didn't exist before. There's a company in the Netherlands called CNC Mushrooms, actually, yeah, CNC mushrooms, largest mushroom manufacturer, food mushroom manufacturer. They are a place where now building microcomposite manufacturers can sit within and produce and grow. So as a designer, all you do is you ship off a file. They make the grow trays, they grow your materials, they ship it closer to the consumer. And I think it's those types of enterprises that we need in order to make the most of the infrastructure that's already there. I mean, when we were growing for an exhibition in Liverpool with 200 participants around the city, we had a huge problem because the mycelium arrived super early, and we were afraid it was going to start growing out in the street in front of the museum. And we looked all over, and eventually McDonald's were like, you know what? Just store out, you know, all 500 bags of mycelium in here because we don't need the space. They rented it us for £2 a square, I can't remember, square meter or something. It was amazing. So I think there needs to be more collaboration between our food, agriculture, and building materials sector. And that might speed up and bring down some of the costs that startups are bearing, you know, biomass startups. But I don't know. I think the speed is always going to be there. I don't know if we can go back, you know. I mean, just given the scale that, you know, the building materials industry is in demand. But maybe there are interesting models, you know, for consumers also becoming part of, you know, the production cycle. Urban farms that we work with, they start growing their materials on site. So a lot of our work are in collaboration with urban farms that have a lot of waste, and then they have a microcomposite grow chamber, you know. So maybe through distributed production, you know, we might be able to start growing these materials. Yeah.
So in this very inspiring talk that you gave us, you mentioned that a shift to bio-based building materials by 2060 can replenish the carbon pool and reduce the atmospheric carbon. How do you think we can achieve that? And what can we do as individuals in a consumer society where the ability to make trash is regarded as a form of power, and also the concept of disposability is promoted many times as the ability to make people feel rich?
Yeah. It's such a good question because there's a level of discomfort and aspirational identity, cultural identities that don't necessarily go with, you know, I mean, even getting people to sort out their trash is a huge issue, you know, in terms of time and convenience. And, you know, frankly, being able to have someone take care of your waste, you don't see it, is also a sign of affluence. I think, you know, for me, producing and being able to see where materials come from and the waste you produce is so powerful, because you realize there is nothing like this is just going away. But that can't happen everywhere, obviously. I think it's, I think most of the work, I mean, the technologies are there. I think the biggest shifts that need to happen are cultural, you know, as you rightly point out. And this is why I think, you know, for a lot of the work that we're doing, we need to be engaging with the public. We need to be, you know, being able to sensitize people to natural materials once again. They come with their smells. They come with their looks when they're wet. They may not be as quick to condition our air, like pressing a button and getting cool air from an air conditioner in a matter of seconds. So there's a lot of mental work, you know, being able to sit in discomfort for a while. How do you make that sexy? And I think we need a lot of multidisciplinary collaboration to, you know, form a new type of culture. I think this is an area we're constantly underestimating. In a lot of our work right now, we're looking at how to customize these materials. So now that they're strong enough, they're high performance enough, how do you convince people to buy them? And often customization is the thing that gets people over the hump. And so we've stumbled onto the world of bio-based color, which is a big big, we like to call it plantone, not a pantone, but a plantone. And that's a beautiful way, a form of biophilia, you know, helping build these relationships between people and materials once again, you know, so that they form new identities that are in concert with our values, our shifting values. So I think it's a cultural shift that needs to happen. And we need a lot of collaboration between the humanities and the sciences in that regard, you know.
Yeah. You have lived in many countries, including England, Grenada, Malaysia, Philippines, Ghana, and the US. And also, like, you were talking about, like, you have been working with coconut, but coconut is not the same in every place. So how do you believe the different social, economic, and racial context in these different places influence your work with materials and also the ways that you are taking to repurpose?
Ooh, wow, that's a I don't know. I think maybe the most honest way I can answer that is, you know, growing up in these very different contexts, my brother and I were always the outsiders. And I think for a long time I saw that as a burden. But I actually think the outsider perspective has been very helpful in trying to move across these different cultures, disciplinary cultures, intersectoral cultures. How does one begin to form a relationship with very different cultures in a farming cooperative versus, you know, an engineering lab? So I think that's given me an interesting perspective and sort of a way to navigate, you know, those areas. But maybe from a, you know, I think the diversity of the different climates and geologies around these materials, I've come to more deeply appreciate, you know, from that background. And that, you know, in the work that we're doing, there might be a different model of standardization, that not all these products have to be homogeneous, that there might be a way of achieving some range of predictable performance when you have materials in collaboration. For me, you know, a lot of the work with coconut was a way of bridging sort of this outliers to the waste industry in West Africa and these up-and-coming bioadhesive companies in upstate New York. There was so much in common because both these contexts are post-agricultural, fantastic expertise with plants, and all of a sudden seeing that commonality with, you know, manufacturers and farmers on both sides of the ocean was something I don't know I would have appreciated having not lived, you know, in those two places. So in as much as, you know, these materials need to become local, I do think there's a concept of translocal, right? That different locales can have something in common and can work together, you know, particularly to resist some of the, you know, issues we face in terms of climate change and toxicity and costs, you know, going through the roof. So, yeah, hopefully that answers part of your question. It's a good one.
So the scholar Susie Gadlick viewed the primary role of the artist as similar as a social worker, highlighting the importance of those who clean up the environment and also provide home for homeless people and show kindness to marginalized groups like garbage collectors or maybe kids, people from the street or drunks. I would like to ask you if, as an architect and artist, do you feel this is your responsibility to address these kind of issues?
Yeah, I mean, I think, I don't think architects can solve all these problems in a building or in the built environment alone. But I do think that one of the key things in the way we work, we like to call the way we work a methodology of generative justice, which this is an idea that you begin with trying to identify in whatever ecosystem you're in where there's alienated value that is alienated from its context, physical and social. And so land might be alienated. When we see land in monoculture farms that are exhausted, that's a form of alienated value. If we see farmers who are getting nowhere what they are actually contributing to a market or a value chain, they are alienated labor. Even consumers who have no idea what's in your food or in the building materials that your houses are surrounded with, that's a form of alienated value. And how do we then, through the processes of design, unalienate people, build those connections, and allow value to return more equitably? So this idea of identifying value and then justice, circulating that value, has been core to what we do. And it gives us a reason why. Why do we design a panel that way, or a building material with these materials? I think it gives us a direction, but I think more than anything, it's a collaborative effort. I think what we're seeing are the symptoms of a toxic system, and there's a bigger project to get to the root of that, which architects are not alone in, trying to address those, but they're part of a much larger team,
You are also a professor, so as an educator, how do you see the future of architectural education? And what is your approach to educate young generations to become responsible artists and designers of the future?
Yeah, I don't know if many people here are architecture students, but in our field, when we talk about environmental design, it's always about building physics, mechanical systems. And that's a very outdated world. 21st century sciences are all about biology, chemistry. Think about indoor chemistry, outdoor chemistry. And so we've undergone a massive shift in our curriculum at Yale, where we're trying to bring in these really complex topics into the classroom and introduce methodologies. So for example, last week we banned students from using materials for their models. They had to grow it all out of mycelium. Yeah, it was not fun, but yeah, they're gonna do it, There's just so much waste at the end of the semester in our bins. We've also tried to do more embodied exercises, so our students stand outside and understand the sun path in a way that before it seemed outdated because everybody could do it on their computer and simulate where the sun is. Now you go out and you draw phenomena that you could only do if you were sitting there and observing. And so I think it's going back to basics like that. I think it sediments in the students in a way that it didn't before. And I think there's just so much happening out in the field, and so getting a lot of practitioners into the classroom interacting, I think is part of the way at least we're trying to address it. But I do see a huge shift in my students coming out every year. They're so much more engaged, and honestly, they want to do things that I wouldn't even think about doing, They're ready to start companies and, experiment in a way that I think we were a little too afraid to or didn't know how to. So, yeah, I think it's a bigger project, but I think in the courses that I teach, it's trying to bring some of the things that, we're literally just learning into the classroom, and also having students test and push us, to ask the questions that we sometimes take for granted, Yeah.
Since we're both having this conversation and we are women from minorities, I wanted to talk a little bit about feminism and ecofeminist look at sustainability as a characteristic inherent in women's work and ideas. But at the same time, the African scholar Philomena Chioma study raises concern about whether sustainable development can be promoted if women continue to be marginalized in a man-made environment and in a management and allocation of resources pertaining to the human shelter sector in most of the modern context. So as a female architect in a still male-dominated industry, how do you see your role and also the role of women and underrepresented cultures in the development of the use and the use of future material technologies?
Yeah, I mean, I think in architecture, we're doing pretty well. I think it's 50-50. Yay, architecture. I don't think it's the same in a lot of other disciplines. So, and especially when you start to look at the materials manufacturing industry, I don't find a lot of women masons or women timber workers, particularly in management top-level positions. And I think that is really important. But this is not to say that women haven't been playing a vital role. I mean, I think in biodiversity conservation, it's women who are preserving seeds, right? And introducing, seeds that have not necessarily been valued. They've protected them. I also think that in the agricultural sector, particularly, I would, again, in the global south and the global majority, women are in biomass industries. They're collecting wood. They're sorting, they're taking the waste off fields, they're working with natural fibers, but often a lot of that work is subsumed into the household daily rhythms, right? And it's the men that are in positions of transaction, in terms of selling timber and whatnot. And so it's more, how do we make visible and value the work women are already doing? And I think that has to happen from a policy perspective in a big way. How do we start to get women in leadership positions in the biobased industry? Because we often see that that's a snowball effect. Once a woman sees, wow, this woman came from my background, she's running an entire mass timber firm, we then begin to see, other women following suit. It's a very powerful driver, stimulator for that. So a lot of that work needs to happen at policy level, because often, and this obviously depends on where you are. I think one of the big things in the biomass world is when we started to look at labor equity, because again, children working in agriculture is a very touchy subject. And it's difficult to just say, hey, no children working on farms. They're very different cultures. And so one has to work with different types of governance systems at the local to national level, to ensure that, the child's education is protected, but also that, their practices are also safeguarded. So it's a complex issue, honestly, but I think where we can bring in women into leadership in biomass, and we've seen great examples of that. I mean, in Senegal, there's a woman who now owns one of the thriving earth masonry companies there. And if you look at her team, I mean, you begin to see, that sort of snowball effect. So hope to see more of that, yeah.
I believe you are inspiring many women and maybe like female students with your work. I'm not sure if this is related, but one of your courses and also one of your ongoing research projects are called Soil Sisters. Could you tell us more about this project and where the name is coming from?
Yeah, so Soil Sisters, yes, that's the name of a course I teach, but it's also a research area at the center where we direct PhD research at Yale. But it was, we started to think about all of the problems sometimes we come up with when we're making biomaterials. And we decided it wasn't good enough to just have criteria for these materials to make it into a building, but we needed to think about 3 lives down the line. How eventually do these materials return to the soil safely? And so this idea of how do you design materials for soil health really drove what we call Soil Sisters. And so there's a range of material classes that we've developed that capture, these different types of materials. So, for example, we have a material class called Material Bank. So this idea that we need to take off urgently plastic, textile waste, paper waste off our landfills. They're not the ideal solution, but they are going to buy us time. We dilute and we bring them into safe products and buildings. And then we have another material class that's called non-toxic circular. So circularity can be toxic, right? If we're introducing components there that are just staying within the system and disintegrating and whatnot. And so the idea that you make choices around your binders and your additives, to think about how they might be non-toxic is another class. But ultimately, the goal is the regenerative class. And that's a tough one to get to because, it's expensive, they haven't scaled up. And so, for example, those would have to be with materials that are earth masonry that don't use cement as a binder, and then they're plastered with a range of biobased or clay paints. But they can be recycled, and the way that they're sourced and used is very much in concert with promoting multi-cropping systems, healthy soils. So you don't take from some layers of the soil because those are important for agriculture, for example. So yeah, Soil Sisters has been a very popular class. We take the students to Ghana and Senegal and other parts of the world in the future, but we begin to work with the textile, agriculture, and building industry to collaborate on new types of soil sister materials. And I think it's probably where a lot of the work is going to go towards, because this idea of soil health is really instructive in terms of what you can and cannot use and how you would process, starting with the end goal in mind. Yeah.
I have one more question. So, some time ago, architect and engineer Arthur Huang stated that switching to plastic made from plastic instead of fossil fuels will require vast amount of farmland, and this could cause environmental problems and deprive humans from food. What do you think about this statement? What are your thoughts? And do you think it's possible to keep a balance between food and material production when creating bio-based materials?
Yeah, yeah, absolutely. I mean, if we were going to substitute all plastics made from fossil fuels with bio-based, we're going to have a problem, because the materials that we use for making bioplastics today are coming from sugar, starch, corn starch materials. These are huge monoculture, industries. Yes, they are far less carbon intensive. If you think of PET or polypropylene, I mean, these are carbon footprints of about 6, kilograms of carbon dioxide equivalent, right? And something like PLA is 1/10 of that. So they are lower carbon, but if you begin to see what they require in terms of land and what those monocultures do to displace land and it's going to be very problematic. So diversification is key. How do we biodiversify the feedstock for bioplastics? And I know nothing about that. I don't work with bioplastics, but I know that the models that exist today are terrible. And I'm writing a book on sugar and corn because those two are like the epitome of all our value systems with plants. Sugar cane is a very impatient plant. So if you don't squeeze, the sugar out of its stalk within 48 hours, it begins to rot. And that's why you need a large labor force. And that's the beginning of transatlantic slavery. All of a sudden, if we're growing at scale, we need a large labor force. And corn is super patient. It can be stored for years, right? And we've seen what happened in the United States during the World War I, when we have an excess of corn building up World War II, the Cold War, so much corn. What do you do with all that surplus? And then we see fructose syrup, right? We see it's used as a biofuel, as an animal feed. When we start to value a crop intensely, and we look at the history of corn, we see how it begins to displace all these other materials. I mean, corn displaces sugar as, fructose syrup. And so we need other models, I think the bioplastics are buying into that model. maybe mycelium are buying into that model, frankly. We need new paradigms for biodiversity. We need incentives, for these new approaches in terms of biodiversity, more than ever with the building environment, because right now, food has a huge demand. Buildings are going to exacerbate that to a huge degree. So the minute the building industry comes into that equation, we're going to see huge problems. I think it's a huge warning sign, and that's the reason it scares me, when I think of scaling up biomass without a new value system, around diversity. So,
okay, thank you so much.
We can open it to the floor if we have questions.
Early on, you show us the 3 projects, and all of them are in non-architecture context. Like, it's not a building exactly. It's more like an exhibition, and you talk about like art context. And I think this is also, it's the same with us a little bit, that when we want to build something, do something new or interesting or like non-conventional, you cannot really do in architecture directly. You have to find like art context. And I just share this just to get your opinion over this, because it seems that architecture is very stiff in accepting new things or new value, or perhaps architecture it's dealing a lot with commercial values, dealing a lot with investment, and people are not willing to take new things or to take a risk. So I think in your case it would be even more difficult, because it's a new materials, and usually these kind of big project or real building, they really need a certainty. Yeah, I like you to share a little bit on this.
yeah. Oh my God. Yeah, I think the built environment is incredibly conservative, right? And often a lot of our products are more expensive to begin with than what's on the market.
It's very limited as well.
Yeah, I mean, you have to find the right client and patron, to start to use these works, these materials. We've had like building developers approach us to say, hey, why don't we use the mycelium for insulation? And then they look at the cost and they're like, that's not going to work. And I'm like, yeah, because who cares about design or value when no one's going to see it? It's hidden in between in the wall. And so I think, I don't know if my work, I'm going to be honest with you, is to scale it up. I think I want to work with people who can scale it up, but I think shifting the public perception of these materials, showing what's possible, because the barriers are the things we did not expect. BMW almost replaced all its car insulation with mycelium. That would have been a game changer, right? And they didn't because of something you could not even predict. It was smell. It didn't smell bad, but the new luxury car smell is like, it's just VOCs coming at you, but we cannot disassociate it from just a fresh new car. You love that smell. I love that smell, right?
It's not a new car.
What? No, the mycelium on a hot, humid day in a closed environment becomes more mushroomy.
Yep.
You don't, it's hard to shift that, And I think that's our job as designers, So we started looking at mycelium strains that produce aromatic compounds, right? And there was one we found in our that only ate the skin of beets.
Okay.
And it produces vanilla, the smell, the aromatic compound vanilla. Do you want to smell vanilla all the time? I don't know, but it was a start, And I think we need to be doing a lot of that work to socialize, some of the properties of those materials. And that's not easy work to do, I think sometimes the art world allows for that to happen. I also feel like in the art world, it allowed me to prototype how you can grow distributed. You don't have to have the centralized factory model. You could have 100 urban farms doing this at scale and selling it closer, to where they're needed. And I couldn't do that in the lab, and I can't do that with a grant. But in an art exhibition, a biennial,
They allow.
you could do that, and you get people understanding, the process. They're engaged, and I think that's sort of part of the work. But I think more and more the work now needs to move out of exhibitions into real world projects. So on our life cycle, I think I would love to see like a policy that starts to bring these materials into buildings. And for me, that's going to be insulation, in tropical contexts, because if you can insulate your roof, you really reduce heat gain by a lot. And so that's maybe one low-hanging fruit that we're trying to work with. And very little design there. Just how do you get a robust insulation into a roofing sheet? Yeah, I don't know.
Another issue you just touched is social perception of all this material, especially like you said, like the smell of the mycelium materials towards the new BMW car, right? And because we are used to everything kind of pristine, sleek, and mostly no smell. If there is a smell, it has to be kind of almost artificial smell. So we feel a little bit safe, or this is new, this is clean, or even the smell of disinfection liquid would be more welcome. So do you think we have a kind of strategy to shift this kind of perception?
No, absolutely. I mean, I think we are so antibiotic, right,
Yep.
in our indoor culture. And I think this probiotic approach, I know that sounds weird, but actually we need probiotic architecture.
Okay.
And maybe it's actually, I mean, when you're sitting in a building that is painted, you are inhaling so much VOCs, super
God.
toxic for your health.
Chemical thing.
And 10 years down the line, it actually doesn't go down by a ton. So how do we make people aware of all of the negative effects of an antibiotic culture? It's one part of it. But also, I mean, you see this in healthy buildings. I mean, the most rigorous green standard in the world is the Living Building Challenge. It's very difficult to get. But they have a criteria of biophilia, and it has everything to do with how do you connect people with nature. And it's through the smell of materials, the look, relationship to daylight. I think there are aspirational things design is already, beginning to talk to, to address this. You can't tell the difference when you enter a healthy building and a building that has a ton of synthetics, because you'll feel it eventually, after sitting in there. But I think we need more probiotic. I think we need to push also what people think is clean, and acceptable, but it's risky to do it in a real building, so maybe start with a pavilion or a biennial where you can start to, I mean, it's not an easy, this is why the cultural work, the work that we have to do psychologically is the most challenging, Even like with bio-based color, it's never flat. There's always a gradient or some kind of patch or luminosity. How do you make that attractive again?
But actually, there are a lot of now contemporary material that try to imitate that, like the floor, the ceramic tile that look like raw earths, for example. That's kind of irony.
Yeah. We have problems, definitely.
No.
Yeah.
Or like a lot of material that try to look like faded wood surface, right? But it's plastic.
Yeah.
Okay.
I have a question. Maybe you answered already a little bit. So I was wondering, instead of like we waiting for a big company to produce this type of biomaterial, is there a way we can do it like DIY style? And is there a way that we can expand this? For example, like your coconut bricks. It's because what you present is you build it into the lab, right? But is there a way that other people can do it?
Yeah, absolutely. I mean, I think one of the reasons why we moved away from the coconut panel was because it required relatively higher temperatures and pressures, and no one has a 75-ton press in their house just sitting there. But mycelium you can grow as long as you can cover it. You can grow it on your shelf, in a box, in a room. And then the geopolymers, these ones are poured, into a mold, and you can produce them in a home environment. And so I think absolutely, and I think mycelium has been the Trojan horse for this. We see workshops being done in middle schools. We do it in our own university in the lab, and growing with homemade objects. I didn't show a number of projects, but using buckets and bowls and all sorts of things you can find in your kitchen to make a lamp, to create your own packaging. I mean, we've seen this is really taking off. I think mycelium. It's just the cost of the mycelium, the high-grade mycelium, is quite expensive. But hopefully, when that cost comes down, it'll be even wider. But I think earth masonry has a lot of promise. I think if we need to think of new types of earth masonry. So, I have a student who's working with earth masonry that is only looking at construction and demolition waste. It is another layer of earth or masonry material. And we've seen some great examples of people being able to allow people to take construction demolition waste that is pre-processed on a site and use it, in their own smaller scale construction projects. Bauhaus Earth in Germany is a great example of that. But yeah, I think the more that we can normalize, these materials, I think we'll see even more great examples of people growing, in sort of larger scales for home or office, applications. At the moment, it's still quite controlled. Yeah. Any questions?
Hi, I was really interested in the way you talked about alienated value. And as a private person, as a consumer, I sort of feel like a piece of alienated value. And one of the things I wondered if you could talk about was the idea of choice. Like, I think a lot of people, at least in the West, like I happen to live in England, a lot of people want what you're talking about. I listen to you and I feel like there's hope. And yet when I talk to my builder, it's a constant, and he's always a man. He's like, no, you can't do this about everything, whether it's non-VOC paint or, in particular, boards that are Botox free. And so I'm just an ignorant person trying to do something, like many consumers. How do I make any part of what you're saying happen, or do I have to wait until all the policy changes? Because I want what you're talking about, and like yesterday. So, how do we bring it on?
Yeah, no, I hear you. I think I mean, in any given situation, there's a less bad choice to make, when you're buying. But the ideal isn't necessarily always there. But I think in the last 5 years, I have to say, because before that, I'd say before COVID, almost every manufacturer we were working with, bio-based company, collapsed. And we were thinking, wow, like, this is not feasible. But in the last 5 years, we've seen a huge resurgence. Now there's like the world's largest bio-based prize called Built by Nature Prize, and it's €500,000. I mean, it's a lot of money. And and I'm just shocked at the number of startups that are out there producing. Now, I mean, I'd say they're medium-scale companies are all around the world, including in England. And I would say to hunt for them because they're there and they're looking for customers. It's just that our conventional distribution channels haven't tapped into them yet. But there are there if you look. The other thing I would say is, there's a ton of stuff from our homes or in our neighborhoods that are produced as waste. If you start to trace where those materials end up, you might find at the end of a material life, that something interesting is being done with them. We found that out, in our school when we were trying to make these cellulose panels from paper waste. And we traced where all our paper waste was going from in the school, and it was a fantastic company that was making paper products, and we ended up doing a whole project with them. And I'm only mentioning this because we didn't know that existed, but the breadcrumbs are there. Yeah, I don't know what to say. I mean, it's not, I feel like maybe I'm in my echo chamber, so I see a ton of these enterprises coming out now. But I'm happy to give you a whole list of them. I mean, there's just one website maybe, Healthy Materials Lab. If you just look out for them, they have a fantastic library of producers all over the world, and often don't come at such a high cost than what you're already paying. So Healthy Materials Lab, if that helps anybody.
Hi, I thank you so much for your honest sharing, and especially about the people's perception on modernity part. And I have a question about the work ethics. So I'm very interested in when you do the practice on these detoxed materials, when you work with actual architects, designers, and workers that produce these materials, how do you observe these kind of new materials shifted the dynamic between different parts of practitioners? And for example, you talk about generative, maybe is it a more generative process? Or yeah, I'm just very curious how these workers collaborate.
Wow, I've never been asked that question before, and now I'm trying to think back. I think there's much more, I think in the beginning, I saw a lot more competition between bio-based companies, especially if you're going to start challenging where I'm getting my corn from or hemp. And I think, for example, in the coconut corn mycelium panel, we found something unexpected when we made that panel that caused the mycelium company and the soy company to work together. So often when you make those panels, you spend a lot of time cutting them after they're pressed, which I know it doesn't sound like a lot, but when you're producing thousands, it's a lot of time. And so we kind of came up with the soy company of a way of sewing a pillow, and you just pack it with a mycelium, and then you press with the coconut fiber on top, and you didn't have to cut. It saved time, and it was actually stronger. And I saw, a whole new way of producing these medium density panels, and it offered a collaboration between them. And it was a healthy one, which hadn't existed before because they were two of the only ones in upstate New York. On the farmer side, I have to say that because we pay farmers now for their waste, they've always become more interested. In fact, they want to become the ones that pre-process or process their waste. And it might be the direction that I could see this going in because, for example, if you're collecting coconuts from this, urban places in the city where they're drunk fresh, you're going to go broke very quickly because it's so much energy collecting. But if they started becoming more invested in this, so they're like, can you make smaller scale mills, that could shred the coconut husk, and we could take the light fibers, transport them much easier from very few collection points in the city. So I've seen them become, I would say, they have more authorship and interest than they did before. You know, in fact, they were criminals, because essentially, if you're illegally burning these materials at night, they're always on the run, you know, in terms of being caught, you know. And all of a sudden, they are actually empowered economically and also creatively, you know, in using these materials. And so, I mean, it's wonderful to see that, you know, they're incredibly smart, you know, street smart. They know how to navigate the city, and they understand how to work with a whole host of people to bring these coconuts in from the village, you know, efficiently. And so it was like a privilege to, you know, be part of that. And I would say, like, from an architect's point of view, I think it's given us a lot more, it's given us a seat at the table, because I think architects have lost their seat at the table. I got to be honest. I feel like we're no longer on decision-making platforms anymore. And, you know, you think back to the days of Robert Maillard when he was building concrete bridges. They were in control of the manufacturing, and so they had a say and real value, you know, at the table. And I think the business model for architecture, sitting, working for the, you know, wealthy clients and building owners, that's an outdated business model. Architects have a huge role to play in the underbelly of this value chain. And your client is not actually who you think it is anymore. So I think it's given architects more expanded territory. We've become more interested in the research, and I mean, I'm speaking for myself, and I think we have a lot more to offer. You know, so one of my students graduated, and then during the pandemic, started her company collecting waste from houses in New York City, and then exchanging that for fresh vegetables, you know, from farms that take their compost. So it's like a, you know, and I would never imagine my architecture student owning this business. Is huge. They're in the New York Times. They supply a huge part of Brooklyn now. But spatially and materially, I think these are all tools that come from architecture, and yeah, a completely different pathway. But I think it's exciting, you know, to also think of other models of where architectural thinking and skills can also be of value. Yeah.
Thank you for a really thought-provoking lecture. I have a question about the lifespan and care needed for bio-based material in comparison to mineral-based. Like you already mentioned the need to change public perception of the smell or aesthetic of bio-based material, but do we also have to shift the understanding of how we care for our buildings and living space if we're gonna use more bio-based material?
Yeah, absolutely. I mean, one of the questions I always get, I'm surprised it hasn't come up yet, is what about fire? What about mold? I know it's bad, I get it. But honestly, you're only going to get mold if you don't allow the material to breathe. If you trap moisture on its surface for more than 24 hours, mold is gonna come. Fire, again, is, you know, is deep in our memories with these materials, is entrenched there. You know, I was talking to somebody whose grandfather was from Benin City, and it's where a lot of these important artifacts, the Benin bronzes, were looted from in Nigeria, and an entire kingdom made out of earth and natural fibers was burnt, you know, in a matter of hours. And I think the vulnerability of these materials are deeply associated with some of the things like fire that we find very challenging. But this is where I think design plays a huge role. Like if air flow and you know how we dry these materials are the things that are going to impact whether they burn or they get moldy, then we need to figure out how to design porosity, you know, and control how air is moving through these materials. And they're much healthier fire retardants than the ones we have on the market today. Algae is a huge area for fire retardants development. And so I think healthier fire retardants as well as design, you know, has a huge part to play. But, you know, taking care of these materials, there's a fantastic company in upstate New York called Stash. And they essentially have a new business model, going back to the other question. And they essentially have a service contract with building owners. it's almost like a carpet company. So I sell you the building material, but I own it. I'm actually only loaning it to you. And I care about its quality because I will have to take it at the end of the day. And it's a fantastic model for restaurants. So I don't know if you guys have Shake Shack here. So all of Shake Shack's furniture is supplied by Stash. And it's a restaurant where you have high wear and tear of furniture, you're always going to need repair. And so you can lean into that repair model as a value generation. I mean, we see service models becoming everything from our cars and all sorts of things. So I think the building sector needs new models, you know, for ownership and the repair and care of these materials. I think the more we try to make these materials last forever, the more toxic they become. And so if we're replacing the faster moving materials like acoustics and insulation more often, what are the businesses that are going to be there to take the materials and responsibly process or, you know, send them for end of life? So I think on an individual as well as like business perspective, we need new models, you know, to work with these materials. But I mean, for somebody who grows mycelium materials, that has taught me, like, you need to care about the environment that they grow in. It has to be healthy, because if you don't, an infection is going to happen. And so when my students leave and they're growing materials and come back and they're mushrooms, like dinosaurs, I'm like, you can't do that. Like, these are living, you know, materials. And so I think there's a certain aspect of lab culture, which actually is helpful in the studio. It's about respect, right, and care that these materials can grow healthy. So I don't know, I hope that perpetuates into how people work and relate to these materials in buildings. But yeah, we definitely need to design differently and think about the end of life. You know, hopefully that answers your question.
如果我们有朋友想用中文问问题也可以，我们可以直接翻译。I want to return back to the title of this talk, Against the Botox and Negotiating Comfort as well. You're giving us so many ways of doing things and how in this whole presentation and conversation. The kind of against Botox, against speed and time and scale. But then also you were also giving us a way of kind of looking into doing things. For instance, we are not privileged enough to not use plastic anymore, but then it's how then we process the plastic and filter the plastic after. And then it's also kind of the fire, it's not how to prevent that happen from the material level, but then it's how then we regulate the air around it. And I think all of those are strategies that is, against. And I found that so interesting. And then I think my question to all three of you is comfort. I want to go back to comfort. Is that how is comfort underpinning the way you work? Because I know in Marcela's work with interactive media and also looking at also the fashion industry as well as how the materials are being used, you know, it's the things that we wear, the level of comfort is really kind of embodied as well. Comfort in your work, Mae-ling, and then also comfort in your work. Rashapon, please.
It's interesting because I started to notice the idea of comforts way back when I started to teach architecture some time ago. Well, long time ago, let's say. And I realized that students didn't understand how it is when it is hot. Because they've been always in air-conditioned place. Like when you comment that if people have to walk from here to here, it's going to be so hot. What do you do? And they're like, what do you mean? They don't understand because they don't. First of all, they don't walk. Second, they've been always in the like they call it like the perfect temperature control environment. To when I think in our system would be like something around 24 degrees Celsius and humidity of like 50-60%. And they're always good. They never need to understand the time of the day or the season because it's always the same. And they move from one environment of a house that is fully aircon to a car fully aircon to the school that is also fully aircon. So they just kind of move from one to another with a super short transition period. So as an architect, it's very difficult for them to imagine like different season, different time of the day, different environment that is not comfort. And that is the tough moment for me. And like, you should go out to stay there. I said, no way. And then it gets also into like client or people who actually use our service. They're always worried about if it's going to be hot, if it's going to be like leaking or like flood with rains and all that. So I think we're just too kind of scared of all this natural environment, like too hot, too cold, too everything. We want something very static, very like static and always there, which is a bit like a fridge. That is what like usually people want. And I start to kind of give them options. Let's say, okay, you can have aircon, but then I give you also the cross ventilation. When you are too hot, you can use aircon, but in general, you can probably use also cross ventilation. We have like enough roof insulation, enough openings for you to get a little bit of the breeze. And I think I'm saying this also in the context that I practice in a tropical climate, which is easier to deal with. Like we are never in a super cold environment, so it's easier. And I think people start to shift this. Some of the people who live in this kind of space, they start to understand, it's not that bad. It's not as bad as I imagine. Like the last project that we just did, it's a small chapel in the middle of like Bangkok suburb. And the priest who initiated the idea of this chapel, he realized that during COVID, the church that he managed could operate because they could open everything. People can come to the service because it's completely open. So he wanted the new chapel to be the same. So I said, great, because if you want natural ventilation, we don't need glass. Your budget will be cut down by 20%. And I think we use that to give them incentive as well. So, but at the end, when it's rain, it gets wet a little bit. Even though we did a lot of simulation of it, where maybe it could be okay. And then I asked him, okay, finally it gets wet a little bit when it's heavily rain for a long time. Shall we kind of do something? Shall we add some elements to help? And he said, you know what? I realized that it's not that bad. It will be like the most 5 days a year, and we can clean that. So I think it's the attitude of like, how do you deal with comfort? And you have to give a chance. If people are brave, you can give them all the way. And if you can, and if they're not yet, you can give them halfway. And so gradually, for the time being, I think the biomaterial is not yet there because they don't have really a chance to use it yet. But I'm sure that if we can shift perception of people in the comfort, also within the smell. I think smell is part of comfort, not only temperature. It could be. I'm not saying that it will be fast, but it's just a matter of how you allow this to happen.
In terms of fashion that you were talking about, I feel like comfort is not something that people are looking for when they are choosing what they wear. Like in history, we have seen also like in African tribes, like they use like these rings to deform their neck because it's like social status, or even in China, bending the foot, deforming the foot to make it small. So it's mostly not about comfort. And actually, nowadays we are making all our clothes with plastic, not because they are comfortable. It's more because like it's cheap and it's fast to make. And yeah, and people can buy a lot of them, and then it's more like aesthetic thing rather and to show some identity rather than comfort in clothes. And I'm not sure how we can shift our minds around this, but I think we need to get closer to nature and kind of look into nature and how nature creates these materials, like animals. They make materials, if you see like spiders, they create these materials and then they are eaten by other animals maybe, like it's like nutrients. And that is something that we are not doing, I guess, because like as human you think like we are on the top of the chain and like we can do anything and we don't care so much about like nature. I'm not sure how to do it to slow down. It's something that I was mentioning to you, and come back to nature, and also in this kind of like economy that we are having, I feel like going back to nature is even like a privilege because it's so expensive, and that's also like the problem that we don't value like this smell maybe, or this kind of like touching this material, that it doesn't feel like a synthetic material. But I think like we should go back to nature and also like see nature as like an ally for building these materials, and the animals and all in the planet together, living together, not just like us and we don't care about others. So yeah.
Yeah, I mean, so I didn't really stress on comfort, but like we do a lot of research on comfort, and it's kind of crazy that human comfort has never actually been the subject of like the reason why we're designing buildings. Like conditioning air really was derived from paper making. The first air conditioner was to prevent humidity from affecting how paper was printed. And then it went to the food industry, right, where you need to refrigerate, meats for long periods of time. But then the railroad cabin. So our human body has never truly been the subject. And yes, there were a lot of research that went into the human body eventually, but those were very much based on northern, so Danish and North American young adults. They didn't take into account children. They didn't take into account elderly. And our comfort standards are really around, a very specific group of people. And it's been a lot of work to change that and expand it, right? And so I think this whole lineage of, the greenhouse, when we start to take those technologies and scale them up, plants became the subject, and then machines in those buildings, and never human. So I think we really need to give ourselves some time to figure out what do we truly, how can we have a much more liberatory paradigm for comfort? Because, I mean, we've all seen when you jump into a cold body of water and come out and sit in hot water, or your feet are touching something cool, you can feel comfortable. Like we are so diverse as thermal beings, And I think we need to tap into that. And I think fashion has a huge role to play. If you're wearing linen or some loose clothing, very different, right? So maybe, I think maybe we need more research in that area. And it's happening, obviously. But the other thing I found really compelling is how do we make sweat acceptable and maybe even sexy? Because, we were looking at, thousands of years ago, sweat was something that humans were so good at identifying what was in your sweat. They could tell you what you ate. It was a chemical signal around your health or what you did. And we've lost that ability because sweat is just like, oh, you're just,
hair also with that.
Yeah. And I think we need some fashion situations going on. How do you make sweat acceptable? The smallest sign of sweat, and we're just like wiping it away, and it's a sign of embarrassment and shame and all discomfort. And I think we need something else there. And maybe we can start to tolerate outdoor microclimates like this, and we can slow down. It's not just from really hot, humid to cold, dry. There's a whole set of places in between, like the veranda, the patio, outdoor covered space like Ratchaporn's design. And I think that we need that in our cities. We absolutely do. We can't put it all on mechanical air conditioning systems, Anyway, I'm so surprised everybody's still awake and sitting out here as the sun begins to set. Shanghai is amazing. Oh my God.
Thank you. Thank you so much.
Hi, Mae-ling. 我想问一下，有没有考虑过？等一下，让他们那个大。哦。OK 了吗？Hi, Mae-ling. 我想问一下，就是刚才所说到的这个关于材料的味道、气味 （smell） 的这个问题，你有没有对之后就是这个芳香材料和疗愈之间有一些研究或者是考虑呢？它们之间会有什么关系呢？或者是就是先问一下这个问题，听不到吗
Want to translate for me?
So the question is, just now you mentioned about the smells of those new materials. So my question is, have you ever considered to make connections between these kind of smells with like fragrance healing? Is there something possible relationship to be built there?
No, but I think you should. I mean, honestly, it's such a great idea. Okay. I think we haven't been as creative in thinking about that. I think the closest we ever got to was rain, like the smell of rain, which is not easy to reproduce. And then this vanilla thing, which makes no sense because I don't know, like vanilla doesn't ever scream to me anything useful other than like, oh, I ate a cake, and that was good, So I think that's a great, and I think all these different cultures have very, very deep histories of smell, even home, right? Like the smell of a material aging is very comforting. Grandma's smell or whatever. I mean, there's so much to investigate there, and it really, it's one of the most powerful senses, right? It can take you back completely, and shift whether you like something very quickly. So I absolutely. I mean, texture has been a big one for us. Our mycelium is like velvety soft. It's not what you expect, when you touch it. Texture, we always play with surface texture because it brings people in. People want to touch and see some kind of identity with these materials. But smell, I think, is even more powerful. So I think that's a new territory for these materials, for sure. Yeah.
Thank you.
Because when you talk about like smelt biomaterials, in general, I think of wood right away. Because wood had particular smell. And when you are in the wooden buildings room, you smell wood. So that's how we make like all these biomaterial have a kind of preferable smell. Or we just have to get used to it. I don't know. This is an open comment. It just we are not used to this smell as a material of buildings, but wood has a particular smell, and we are wood or bamboo. You were in Japan just a few hours ago, and it's like it has a particular smell. Or tatami mat has a particular smell, and we are kind of used to it. Yeah.
Well, thank you so much. Thank you so much for being in Shanghai, for being with us, for Rashapon, for programming this. Mae-ling, thank you so much for giving such a generous talk, and also Marcela for this conversation. Thank you. Yeah, so our program ends tonight at 8 o'clock. We'll have film screenings on the televisions here, so you're welcome to stay and watch the films. They're kind of emanating of how Shanghai people used to watch films in the courtyard back in the days in the summer. And then, so tomorrow is Monday, and then Monday and Tuesday we are off because we're also we need to rest. So on Wednesday, we are back on again from 11 o'clock all the way through 8 o'clock in the evening. And then Wednesday to Sunday, we have programs. So please do come back and check out our programs. And thank you so much, everyone, for coming.
What time is your flight?